Source code is typically written in any programming language, but they have a few common traits. Those traits are, there are a minimum sequence of characters or tokens that have some meaning, just like a spoken language, represented by alphabets of the programming language grammar. In adherence to this language tokens, it can be combined to represent a statement like let A is equal to B, or let Q is equal to X plus Y. These statements can be assignments, branches, controls, and conditional evaluations as well. Conditional evaluation examples are if X is equal to true, then do something, else do something else. When you combine multiple statements together, we create a basic block, which essentially becomes a function. And these functions have entry and exit points. Like you see in the screen, we have functions called as name, can pay, spender, etc. Now, as multiple functions connect with each other and pass data in lieu of communication to create a data flow in order to serve a certain business need. As you might imagine, graphs can relate to programming in a variety of ways, because what you see on the screen is a multitude of functions communicating with each other with a certain workflow. And graphs do an excellent job of depicting how elements in your code base depend on each other. You can use them for methods, types, namespaces, assemblies, etc. And in any of these contexts, they provide an excellent window into the architecture and maintenance profile of your code base. Now, as software systems are composed of many interacting elements, a natural way to abstract over these complex relationships is to model the application and its communication paths between its open source dependencies and the frameworks it's connected with using a connected graph. And being an evolving system, an application's entire graph evolves over time, mostly growing and increasing the number of nodes and edges. Owing to this, it becomes relatively hard to assess and comprehend the security posture of your application. Upon grokking at the screen, you notice that there are several communication paths. And if you're using tens and hundreds of open source libraries and deploying on a framework, this whole process of understanding your code becomes fairly unwieldy. So upon grokking this complex composition that you see, can we answer the following questions? Is your application compliant in treating sensitive data with care? Can authentication logic be bypassed in this code composition so that an attacker can abuse a business logic flaw? And if you're using tens and hundreds of open source library, is these open source libraries used in a safe or unsafe way? And is your application at risk of insider attacks? Note that I posed just a few questions, but there's several other questions that could lead to your risk profile of your application, which means if you deploy your application in production, you're at the risk of this application being attacked by a hacker.